We want to look at Euclidean geometry. Euclidean geometry was discovered by a very prominent Greek mathematician called Euclid. The word Euclidean comes from his name, Euclid. Euclid actually liked to play with lines and different shapes, and they ended up discovering and proving theories that are very crucial even to engineering, to medicine, and many other fields of engineering. So today we are going to start by looking at building blocks of the very crucial theorems that Euclid actually proved. So we'll start with these basic constructions. We are going to look at construction 1, which says to bisect a given line. The word bisect means to divide into two equal parts. So if we are given any line segment, let me just draw any line segment here. We don't need to know its length. We just draw a line. Then we decide on a starting point. Let me call this point A. Then we decide on an end point, and we call this point B. So we want to bisect this line, to divide it into two equal parts without using the algebraic method, but using the geometric method. So we can use instruments called compasses. Then we open compasses from point A or from point B to a certain radius, and the radius we don't need to measure to know how many centimeters or millimeters it is, but we just estimate a radius that is slightly greater than half of the line. So it has to be a convenient radius. Convenient means it's easy to work with. So I can just open my compasses without measuring the radius. Then I check also my space to make sure that the radius can fit in. If it's not, I can still adjust. As long as this is greater than half the line, I can adjust. I don't need to measure. So I strike an arc on one side of line AB. Without changing the radius, I strike another arc on the other side of line AB. Without changing this radius, I change the compass point to be at point A. Then I strike an arc to cross the first one. On the other side, I strike another arc, the fourth arc, to cross the second arc. With a straight edge rather, we are going to draw a line passing through these points of intersection of the arcs. So we draw a straight line. We don't need to measure this line as well, as long as it's a straight line passing through both points. Now, at the point of intersection of this line I've just drawn and line AB, we can see that these lines here seem to cross each other at 90 degrees. This we can verify with a protractor, putting the protractor compass at this point here. Let me call this point N. Protractor point at point N, and one of the zeros of the protractor on line AB. We can see that counting from here, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. So this angle is actually equal to 90 degrees. The other angle here is also 90 degrees. So if one angle here is 90 degrees, the other three are also 90 degrees. So it's very safe for us to say this angle is 90 degrees, this one is 90 degrees, and this one is also 90 degrees. So this confirms the mathematical notion that a point is 360 degrees in total. So it's 90 times 4, we get 360 degrees. If we divided this line into two equal segments, we can use dividers to check. We don't have to use a ruler. It's not very necessary. We can, but it's not very necessary. So I can open the dividers from point A to point N. Then I check if this is the same as point N to point B. Distance NB is equal to distance AN. So I've done two things here. Bisecting the line, and we can indicate that NB is equal to NA with short lines. Mathematically, this means that the two line segments are equal to each other. And we have checked the angle is equal to 90 degrees. So this line here is called a perpendicular bisector. Now that's a perpendicular bisector because it's doing two functions. One is actually creating an angle of 90 degrees, and two is dividing the line segment AB into two equal segments. So now we can move on to construction 2. Construction 2 says to construct a line perpendicular to a given line from a given point, and the point is away from the given line. To construct a line perpendicular to a given line from a point away from the given line. So let me draw another line segment. If I draw any line segment here, and I'd like to call this line CD. Maybe this is point C, and this is point D. Point C, point D. Okay. Now, let's locate a point away from this line, anywhere away from the line. So let's call this point P. Now, after locating point P, we now pick canvases. We open the canvases to any convenient radius. But we must check that the radius will allow us to draw an arc that will cross the line CD twice. So putting canvas point at P, we draw an arc to cut line CD twice. If the arc is going out of the line, there's no stress. We just extend the line. We extend the line CD so that the line and the arc will cross each other. We are looking for crossing points. So we have this point here, which is the crossing point of the arc, and this other point. Now, using the same radius or any other convenient radius, we come to the crossing point of the arc with line CD, and we strike an arc. And this radius should also be greater than the distance between the crossing points. So it can be any arc there, changing the canvas point but without changing the radius. We strike the second arc to cross the first one. So this line of intersection of the arcs is a very crucial point. Now we draw a straight line passing through this line of intersection and point P. By so doing, we have constructed a line which is perpendicular to CD. That is the line which is crossing CD at 90 degrees or at right angles. Now, if I may call this point N. Point N is here. Now, if we check again with a protractor, you can see that this angle is at 90 degrees. Putting the protractor point there and maybe one of the zeros on line CD and checking here, you can see that this is 90 degrees. So we have created angles of 90 degrees like in the first construction, And this line here is not necessarily bisecting the line, but it's just a perpendicular line. So it's not a perpendicular bisector like the first one, but this one is just a perpendicular line. Now this is a perpendicular line. It's not a perpendicular bisector. So this line here is just a perpendicular line. So this is a very important construction which was also used by Euclid in circle geometry, one of the theorems. Now let's move on to construction number 3, which says to construct a line perpendicular to a given line through a point on the line. Now this construction is slightly different from construction 2. In construction 2, we're drawing a perpendicular from or through a point which is away from the given line. But here, the point should be located right on the line. So we need to be able to construct a line which is perpendicular to the given line. So let's say we draw a line, any line segment, we don't need to measure. First point, let's call it point E. Second end point, let's call it point F. So we have created line segment EF. And let's locate a point right on line EF anyway, not necessarily in the middle, but anyway on line EF. So this is point P. We want to draw a line that is perpendicular to line segment EF, but passing through point E. That is pretty easy. So we pick canvases, open canvases to any convenient radius, put the canvas point at P, then we can strike an arc on either side of this point P. That is also crossing the line twice. It can be a semicircle, it can be a complete circle. One of the three can work. It can be just an arc this side, an arc this side, a semicircle, or a complete circle. Now, this circle is actually creating construction points where it crosses line EF, those 2 points. Now, using canvases again, we can use the same radius or adjust the radius slightly. Put the canvas point at the crossing point. Right? Now, the distance or the radius or the canvas should be bigger than half of this distance between the crossing points. So I can strike an arc this side and also strike an arc this other side. One side can do, but both sides can also do. So I strike an arc there, I strike an arc there. These 2 arcs are crossing each other at this point and at this point. So through those crossing points, we draw a straight line. That line will definitely pass through point P. So this line is perpendicular to line EF. This angle here is 90 degrees. We can confirm it by checking with a protractor. Put the protractor point at P. One of the zeros either on the right or on the left should be on line EF. And we count the degrees from 0, 10, 20, 30, 40 until 90. We can see that the line here is actually at 90 degrees. If we start from here, the same applies. We can confirm that this is an angle of 90 degrees. So this line here is a perpendicular line to line EF. It's not a perpendicular bisector, but it's simply a perpendicular line. That's a perpendicular line. Okay, that's a perpendicular line. That's construction number 3. Let's move on to construction number 4, which is also very important. It says to bisect a given angle. Remember, to bisect is to divide into two equal parts. If you are given any angle, it doesn't matter how big it is, you can divide it into two equal angles without using a protractor. So let me draw two lines. Remember, an angle is a space that is created by two lines that are intersecting with each other. So if we have two line segments, for example, I draw this line segment and call it BC. Then I draw the second line segment to meet BC at B. So I call this line segment AB. So we've got BC and AB. They are meeting each other at 90. This point B becomes a special point called a vertex. This is a vertex. If there are many, they are called vertices. Vertex when it's one. When there are two or more, they are called vertices. So we don't have to measure this angle for us to be able to bisect it, to divide it into two equal angles. Again, we use compasses. Open our compasses to any convenient radius. We put the compass point at B. Then we draw an arc to cross the two line segments. The arc should cross line AB and it crosses line BC. By so doing, we are establishing important construction points at the crossing of the arc and the line. So I use the same radius or any other radius. I can adjust the radius to become smaller or bigger, but it doesn't have to be less than half the distance between the crossing points. So I can strike an arc here. Now we don't have to change the radius. Once we've struck the first arc, don't change the radius, but change the compass point to the other crossing point, then strike an arc to cross the first one. So we also establish a very important point. Through that point and through point B, which is the vertex, we draw a straight line. So this straight line passing through this point of intersection of the arcs and passing through the vertex of the angle will effectively divide this angle into two angles. This angle here becomes this angle equal to this angle. If this angle is theta, this angle is also theta. If this is alpha, that is also alpha. If the angle ABC was equal to 30 degrees, therefore, one of the angles here, the smaller angles we've created, will be equal to 15 degrees. So this is how we can bisect an angle using a geometric method rather than an algebraic method of measuring with a protractor, then we divide by 2, simply by construction with instruments. Basically, this is what Euclid was doing when he was playing around with straight lines, with arcs, with circles, with different shapes, polygons, and the like. And he came up with different theorems that are very important to us today. That's all for this lesson today. Let's meet in the next lesson where we are going to look at circle geometry. We'll start with theorem 1 until we go to the end, to the last one, the end theorem of a circle geometry.